Hello, everyone, and welcome back to the broadcast. We're going to be picking up sort of where we left off last time. In the intervening period, I think, figured out what was going wrong. Hello, everyone. Hello, Otel and Tass. We do have 4 kitties visible right now. Is that Sherbet? Looks like Sherbet. There's a particular type of bottle cap that he likes to play with. Oh, well, now he found the little air hockey puck for a moment. But we have Ember in her spot and Mason over there on the bed. Sky is passing through. But let's see where we are. Okay, so this is a heavy case scenario here. We have after 6 seconds, the yarn balls split into 3 to the 4th yarn balls, and they are spiraling. Both of those things are expensive. The blobs are spawning in groups of 3 to the 3rd, so 27. And they are orbiting inward and tracking the cursor, both of them not cheap types of movement. And we're getting anywhere from, let's say, 30 to 55 frames a second. So if we lower that down to 27 yarn balls, it should start to recover. So let's say sitting at about 15,000 things, 1,500 things, whirling around the screen and colliding with each other, we're sitting at 120 frames per second. So, good times are being had. Now, to inflict the same eldritch madness on you that was inflicted on me this morning solving this, I'm going to show you what the solution was. Go into our shader collision manager, and I'm going to show you the data structure that we pass in. We pass in an array of these. Now, this is how it was this morning. That's it. That's what I changed. I moved this variable down here. Task gets it. So, I don't know for sure because the GLSL documentation is dense, to say the least. But looking around and finding some simpler references and double checking what I could find, this is actually the problem spot here. This is a vector too. Now, on the data side, it's just a pair of floats, but it's a structure. It is a complex type. Well, it's more complex than just a float, and the reason that's important is because the first thing determines the padding structure, the way this gets packed up. And this is 8 bytes. It contains 2 4-byte chunks, but this is 8 bytes. And that changes the way that it wants to space everything. If the first thing is a 4-byte chunk, it wants to take those floats and say your 4 bytes and your 4 bytes and your 4 bytes, nice in a sequence, I think. So from what I can tell, what happened is that it loaded this one, or at least it started packing here, and then the padding inside of this, however the standard 430 to this GPU gets padded, was wrong. So after that, there was a little bit of a offset. How much? I don't know, but it was resulting in weird stuff. But yeah. It was exciting. Okay. So now we have this running pretty steadily. Now, we're making use of this part yet. It's not even functional. But we do have the option of putting more work within a given workgroup iteration. Are we going to do that yet? Yeah, we're not going to touch it just yet. But here are some additional changes that I made to trim things down. We are doing two-way collision checks. That is, if they collide, then it's considered a source to target and if A and B collide, we have A colliding with B and B colliding with A. We have two different collisions that result from that. If either of them is not allowed to collide, then neither collision, we still make the collision happen. We have to do some extra filtering, but we still make the collision happen. Right here. So this is where we're calling it out. So we still do the initial check. But we avoid duplicates, so if I've already checked 1 to 2, I'm not going to check 2 to 1. We make sure that both of these are valid indices. Really, it's just this one has to come before any reference to an array. Then we're going to check, has this entity collided with the maximum number of per entity collisions? I put this back in now that we've got the function working. This was an added layer of complexity that I wanted to rule out. But what this says is, if either of them has hit its limit, skip it. Because we won't get... we don't want either of them involved in a collision if they're already at limit. Now, I could reduce this down and make it so that it does a per entity check down here. But I'm not gonna for now. Maybe in the future. Then we see, are we already at maximum collisions? If we are, skip it. So this will call down, this one, where is it? This one here handles any overflow, and we always make sure that there is enough room inside of max entities to fit everything as far as this logic is concerned. Or there's enough processing in this to cover the entirety of max entities. Okay. So we get all that. We get the two shader entities that are now properly formatted and padded. We check if they collide with each other. Now this is, we check each individual one. Hey there, James. Yeah, we got it working. Were you here to see what the problem was? Or did you see on the Discord what the problem was? Subtle plug, I have a Discord where I talk about the coding stuff if you want to see more of what happens offline. Yeah, just weird data structure shenanigans. So we check if either of them should collide. If either of them could collide, we proceed into the proximity check, which is just us comparing the distance between the two of them to the combined radii of them. So if they're both 5 wide and they're 10 apart, then that's a collision. If they're both 5 wide and they're 15 apart, that's not a collision. You know. If there is, then if A to B is able to collide, then we try to add that collision. Now, this does the max count checks again because we could be getting some multi-threading nonsense happening before this. And then if the target to source. Hello, 10. Welcome. Bit of beverage. Okay, but this is our shader, and our core logic is in there. Again, I will eventually consider wiring up logic that will let me put more work within a given work group. But for the time being, we're leaving that alone. So we go through, we run the entire set. All the way down here, we can cull this commenting stuff out. Okay, so do basic physics. One of the things we're going to be able to do that I like with the shader is I can control when it runs. I don't have to put that in physics process. If I do Godot level physics, I need to do Godot physics. Which means it needs to be in physics process, it needs to be part of the tree. This doesn't even need to be part of the tree. So we run the shader, then we're going to go over all of the collisions we found. We're going to essentially get the source, get the target, and trigger a collision between them. Which will in turn have the collider, so the source of the collision, is going to send interactions to anything that it ran into. And that one is correspondingly going to potentially receive them and act upon them. I have some thoughts on that. Doing okay, 10. Doing okay. We're moving along. Let's once again show where we are. I believe right now we have under 32,000 for our limit. So this is with 10 projectiles being emitted per second. I'm sorry, no, it's 2 blobs per second, and then it is, I think, 12 yarn balls per second, maybe 10 or 12. But this is an approximation of what I would expect worst case projectile emission to be. Wow. Sky is tussling with Sammy. And that puts Sammy between Ember and Sky right now. They're doing that cat face off. Ooh, I definitely don't remember that, 10. I am bad with names, but... Okay, so here's minimum case. This is a reasonable number of projectiles being emitted. It's also a large number of creatures being emitted. Okay, let's ramp that up. This is a whole lot of projectiles being emitted. Wow. I mean, welcome to the channel, Saint. So at, let's say 2800. Yep, 10. I appreciate you coming to the stream, and welcome back. So let's say 2700 objects, all of them can collide. We are emitting 27 yarn balls twice a second. So let's say 54 a second, and we're emitting 18 blobs a second. I do have a Discord server. Let me see if my bots can find it. Oh, no, it needs to be... I think I need to do this. There we go. I have a bunch of flawed macros, but there it is. Okay, so this is very clearly a high output case. So now we're going to make the movement more expensive. Spiraling motion is more expensive than linear motion as far as processing. And bear in mind that we are processing movement for these about 60 times a second. So we're still holding at about, let's just say 80 frames per second for visual. Okay. Now, this is a very high throughput scenario. This should not actually happen, or we should try to not let this happen in the actual game. More likely, the kind of thing that we would get would be more like this. So, delays between each projectile split. So 3 seconds split in 3, 3 seconds split in 3. So you can see a substantial reduction in the number of entities out there. We can even make it a little more intensive based on where in the flow we add larger splits. Guy is picking on Sammy, and it is disrupting the entire kitty cat ecosystem here. You can see Ember's looking around trying to figure out what was happening. Welcome back, 10. So then we're going to split it into 9 again. So we're hitting our threshold at about 500 active entities. But it's noteworthy, this is still frames per second. Still frames per second, which is significant. And then again, putting a triple at the end is the least impactful. But still, haven't decided on a final name. We're still using a project name, and that's still Nyanite Survivors. Okay. Now we need to carefully ramp this. Here we go. Now, when I said carefully ramp this, that was making one change to the sequence of events, and that was removing a 3-second delay, an extra 3-second delay before we begin the splitting pattern. So we're sitting at, 18,000 things. Now they can spike up. Let me do a. The reason that it's wobbling substantially is 24,000 is the limit. If it hits 24,000, there will be a hitch. But that's okay, because this should never happen. Like, this is a extreme case to put in there. Player power-up wise, a 9 split is crazy powerful. And this is a double 9 split here. So we have decayed frames per second. We're 30 between 30 and 60 territory. But this is, how long is it going to take to complete? Good question. Because we have collision working, we can get back to game logic. We can start getting back to the game logic, which is good. To give you an idea, one of the reasons that we're back, that we have delayed for like more than a month at this point, is performance. All of the rendering except the inventory there. So all of the yarn balls and blobs and all of that. And so drawing them and having them collide is all being done on the GPU right now. Now, I don't know if spatial partitioning would necessarily be worth it, because we would have to do a lot of extra processing on the CPU side, on the Godot side in C#. That might result in extra cost. Might. But on the plus side, we can cross that bridge later. We can double back on that at a later time, because we already have the module that does this. So yeah, complex movement in place, lots and lots of objects. Just getting to like 3,500 of what is almost entirely yarn balls on screen is pretty bonkers. We'll remove the spiraling from the blob so you can see. Even if it took multiple hits to knock out the blobs, nothing's getting onto the screen this way. Yeah, this one looks fun. All right, 10. I am working on getting them posted more reliably. You can also see the heavy splits happening a little bit more in this with this movement pattern. Hello, Ember. Hello. Yes. We're just gonna bask in this for a moment while I give Ember some attention. I mean, I'll take 6 frames a second when we've got 10,000 things active. So this is 3 to the 5th after 6 seconds. Which means that 3 to the 5th only lives for about 3 seconds. A little more than that, but I think it's 4. The lifespan on the projectiles is about 10 seconds, if I recall. So if we cut it down, if we do 3 3-second delays, that means that they split and they only exist for about a second. It's still really expensive while they exist, but you can see them going off like little blossom fireworks on the edge there. Sherbet saw Ember getting attention, and he slowly converged on me. So again, to show the impact of 3 seconds here, there's 3 to the 5th after 9. Here's 3 to the 5th after 6. Massive difference in things on screen and general performance. And this mechanism that I'm putting here is the primary way that we're going to contain this sort of thing. Is if there would be a split into 243, then there would be a massive delay on it that would prevent the projectile from living for very long under that circumstance. Such as this, the projectile only has 1 second of lifespan when it does that big split. So let's illustrate that. They're going to split and they're going to start wiggling. Wiggle, wiggle. So you can see that spiraling pattern there. It's spiraling inward along its movement there. But you can see that only happens very briefly. Cut it down to 4. Hello, Sherbet. So 3 to the 4th, 800 to 900 entities active. We've got 120 frames a second. Effectively unbounded performance right now. pretty good. And again, the collision logic is happening because of these things here. But having looked at this, I don't like these anymore. I feel like it's multiple layers of complexity that actually limit how we can operate. And looking at it, we've already got these. We've already got behaviors, which right now are movement drivers. So if we go into our standard entity manager, we're going to go all the way down here. So if you notice, this isn't underscore physics process. This is manually called by the core game loop. This is one of the reasons that I like not using Godot physics, is I can just do this. So instead of trying to pause parts of the tree and maintain that, try to negotiate with the game engine, instead I'm just saying, if I don't want the physics to happen, I can make it not happen. But anyway, so, we purge out any entities that are going away as of the last frame. We add any in that were being added as of the last frame. And then we call act on them. And this is a signal to the behaviors to take action based on time. So we pass in delta here. So each sub part of a frame, they get this call. Now let's go over to entity collide here. We have these special methods, interact and collide. Now, the trick with this is that it's doing essentially the same thing. We're taking an event and we're feeding it to a series of entities that act as like a timer for lifespan, those kind of things. What if instead we just made these behaviors? That is, the same thing that makes them move. What if that was also the thing that interpreted collisions and actions over time? I wouldn't do it this way, but in theory, that could make it so that the thing that counts whether the lifespan has expired could also be a thing that makes it move or take other actions during each step. A thing that makes it do damage on collision could also have an influence on movement. Would it necessarily do that? No, but it opens up more possibilities. We could have a projectile that shortly after it's fired, it does very little damage. And then a few seconds later, it suddenly speeds up and does a lot of damage. Maybe it explodes. So you get kind of a delayed missile launch kind of thing. The first one emits launches the primary projectile, and then the subsequent ones, after it has armed, do something else. Yeah, stuff like a MIRV. It would let us fully change the behavior at the time of a gate instead of trying to approximate that in the interactions. We could have that baked in, which I like. Where we would iterate over it pretty much the same way. So we go into our entity manager again. So we call entity act. We go into the entity. We look at act. And during this period, it's looking at proposed movement. there are other things that could happen here. So here, for each, we do a time interaction. We could either handle this as part of movement, or we could do this as a precursor where we iterate over each of them and say, this much time has passed. Do you care about that? Because it's possible that one of the things that results from this time interaction is a gate opening. Right here, let's try open. So the first thing that we do would be this loop. We check, is there a gate to open? If there is a gate to open, give it the message. So is this a... first we do the time interaction. And we do actions accordingly. If another event like a collision has happened, and we are sending messages accordingly. So general collision message comes through. First we go through and say, if there are gates, send them this message. Do they care? So there might be a gate that says on impact, do this. Like open this gate. So that would fundamentally change which interactions happen next. Because if a gate opens, any of the prior ones that aren't part of the base entity cease to happen. So if we pop over here again, I can show you that. So this is base movement, how the yarn balls move out in a random direction in a straight line. If I add orbit inwards, we have this spiraling motion here that it is essentially a tightening circle, but its center point, the point that it's trying to converge on, as it loops around it, is moving away in that same random direction. But if I put a 3-second delay, they're going to move in a straight line, then they're going to pick up with that same sort of motion. But the core center point of that appears elsewhere. It's trickier. But if then I put another gate after it, if you watch some of the projectiles that are looping around, they just stop and resume moving in that straight line again. Here. We'll have them stop moving and then split into 3. So that's what the gates do, is I have the base behavior of the yarn ball. It will always happen. The yarn ball moves in a random direction, determined when it comes into existence. Then we have a 3-second gate. That's currently using the homing mouse sprite as a placeholder. This gate is blocking any behavior for 3 seconds. So nothing goes past the base yarn ball behavior for 3 seconds. Then, when those 3 seconds have passed, because I keep asking the gate, hey, do you need to change? Do you need to change? Is this first gate going to open? If it does, we now look forward and say, okay, this behavior is now activated. This one between the 2 mice. So it begins doing that looping motion there. But every time we're going to do that looping motion, first we ask this next gate. Should this gate open? As soon as that gate's open, 3 seconds later, so this one goes away, and now we're doing a composite of base motion and spiral in motion. The next 3 seconds happen, and this next gate goes away. Now that spiral motion is gone, and that means we've reverted back to the base motion. As far as that base motion is concerned, nothing has changed. It is still moving in the exact same way that it was. But it splits into 3. That is the next event in the chain. Split into 3 only happens once in its lifespan. We can demonstrate further by having it go in a spiral out 3 seconds after it splits. It will be very brief. But you can see towards the edge, they start looping again. Now, the reason that I show this again is, what if at different stages during it, behaviors changed? So there might be let's use a very distinct example. What if instead of there being a hard delay with a projectile split, it only had a short delay? Gate. I think all splits should have gates. It prevents some things from being too weird. But what if within that gate, within that split, there is a extra timer that says this projectile will die after like 1 second? That would create this circumstance here, where they behave normally up until the last possible second of their existence, and then they split into 3, way over towards the edge of the screen. So we're going to have them split into 781, 243. We showcased this a little bit earlier. But if we had, that would essentially create this scenario, but almost immediately, instead of happening later. What does that mean for us today? Re-engineering. Because all of this interaction stuff needs to be converted over into a behavior. And those behaviors need extra interfaces on them, extra methods on them that handle the particular use cases. So, for example, a gate, timer gate, is a templatable one, effectively. Because it behaves in a very exact way, in a very particular way. But these are all very particular things. I want them to not just be a gate. I want these to be a behavior. Actually, no. Gates will be different. Gates will be different. Tell a lie. Gates will stay different. What we'll actually be doing is we're going to look at these interactions. Right now we have like, oh, this is a timer interaction. This is a collision interaction. I've got these two different things. They're not going to be different things anymore. They are a behavior. So there will be pretty much all of them are going to be handle message. And those messages will generally have different elements to them. So a base collision message would have source and target. Like, the behavior chain first gets told, here is a collision that happened to you. Those behaviors could subsequently either consume that message and say, I've handled it, nothing else in the chain gets to see it. Or they could also, they could do nothing, they could consume the message, they could emit new messages to be added to the queue of things to handle, you know? Though that's an intricacy I haven't explored yet, is would we handle the messages immediately, or would we handle them in the order that they would have been created? So, you know, do we finish handling the collision message fully before we handle the and now do damage message? But in any event, all behaviors would have handle message and a way to, which would give them a way to react to a message and also emit new messages. Yeah, we'd probably put an entity on this as well. Or each message would have those entities to say, like, okay, here is a new event. All right. So we would add those to behaviors. Same way with a time interaction here. There would be a time has passed style event that's happening. The plus side is we already have this one, and that's with act. That is not a particular event that has happened. That is a opportunity for everything to move. Now, would I separate timers and actions? Maybe. Maybe the time has passed, do you want to change, is a different event than move things. But I kind of like the idea of mushing them together. It's handling how that would go down, you know? Because setting up motion is a little bit different. Let's go into our entity. We look at act. So each one of these is taking action on the entity then. I think we could do that. We could send a time has passed event to it. And each one of these that wants to move is changing proposed movement. Okay. I'm kind of thinking out loud here, so if you don't understand what's going on, feel free to ask questions, or just feel free to chat with me if you like. That is not provocation. Also, feel free to feel free to lurk. Everything is welcome. Okay. So this, instead of it being take action, would be a shift over to entities having all entities would have a incoming message event or method on them. And one of those is a time has passed event or message. No matter what, though, that entity is always going to take that and process it by first giving it to the gates and seeing if a gate opens as a result. If a gate opens as a result, we are going to change which behaviors to use. But otherwise, we then take that message and feed it to whatever events are active now, or whatever behaviors are active now. Sometimes that will just be they move, and they take action according to proposed movement. sometimes that could be things like the timer has ended, go away now. Because that also gives us what that also does is it gives us opportunities for during the movement chain for one of the behaviors to say the movement chain has now ended. One of those behaviors could effectively eat that message. Yes, I like that. I like where this is going. But to accomplish this, we must add some more stuff here. There will be layers to this. I'm going to quickly check and make sure. Have I made any changes? Yes, I have. Some debug prints that we pulled out. Just want to get a little mini commit in there so that we don't have clutter in our changes. We currently aren't using active at all. We can though. I think we can. But we'll get there. Behaviors don't necessarily have a targeter anymore. We could leave that up to a subclass of behaviors that is a movement behavior or something like that. But I'm tempted to make it so that targeter is a part of each given pattern of behavior. So spirals could have a targeter kind of thing, but maybe not. But behaviors will have the possibility of being gated, and which is their key. They have a way of being copied. Then instead of act, it will be handle message. And for the most part, those messages are going to include things like the entity that this behavior belongs to, as well as any other entities of note. Yeah. I think the targeters have largely been okay. Yeah. When you duplicate a targeter, you get the same entity in direction on it. So let's see. Yeah. You give it a direction, it uses it. Okay. So targeters can stay their own thing for the time being. And we'll leave that as part of the behaviors for simplicity. Longer term, what I'm probably going to do is make that something that that a behavior contains if it wants to use it, or if it's set up to use it. That way, we don't have extraneous targeters lingering around, kind of stuff. With all that said, though, we're going to pick up with it and try to hit the ground running after a break. And we're back. It's something, for those not familiar with very desk-intensive work, let's call it, cat finding. One of the things that is a important behavior to cultivate is get up and move around. Get up, move around, stretch, especially your arms and wrists. There are a lot of exercises that are particularly good for the muscles and tendons in your arms and wrists. Developing things like carpal tunnel are real bad. It's real bad. And anything you can do to mitigate or avoid that possibility, you generally should. But yeah, okay. What we have to do is now we have to start modifying behaviors. Leave targeter around here. We are going to have a handle message. Beverage. Okay, so we are going to add a behavior message type here. I want to call these types. So there are movement behaviors. There are spawner behaviors. So movements move things. Spawners are like the split into three. Any behavior that is going to result in extra entities, I would put in a folder with spawners. There's nothing about it that makes it a spawner. They just share a general pattern here. Like, it's still a spread. And in general, a spawner would have a, did it do its job? If it did, it's done forever. Events is very broad, but I think we'll go with that. This is a behavior message. No, this isn't. These aren't. This is universal to behaviors. Now, this is a base type, so it's not technically partial. So let's see. These have a behavior message, will have a type. And some sort of payload to it. But that payload is entirely based on which type it is. Because there's nothing about a behavior message intrinsically that matters. That is, it's only that it's this, and that we know we can get a type. I don't think I'm not 100% familiar with that one outside of, I think, seeing it, the Pokemon Eternatus. Isn't that the one that looks like almost like a gigantic spiraling down clawed arm made of like red panels with blue trim? Yeah. I mean, it's a bit of a back in my day kind of statement, but I do kind of prefer the sort of Pokemon that are derived from animals and objects instead of ones that are trying to be abstract or fully alien, you know? A lot of the newer legendaries and kind of conceptual or deity style Pokemon end up getting a real glue bits together kind of vibe. You know, it's kind of a quadruped. It's shaped kind of like an animal, but let's glue some metal bits all over it and say that it's a god of time. I feel like that was largely unnecessary to go in that direction, and that would extend to gigantic hand monsters. From a sort of player looking in, I feel like adding demigod Pokemon or, again, deity style Pokemon that are capturable as opposed to just being incarnate forces of nature is bad for the setting. It erodes a lot of the life in that world if there is a 10-year-old walking around with God in a Pokeball, you know? Hello, Sky. What you want? Okay, so we have a message. It just needs a type. Okay, so behavior types have, or behavior messages have a type. And then we'll have a series of constants that you would use for the type. Most bizarre creature, living or mythological? Living or dead? Anglerfish. Not necessarily the most bizarre, but very bizarre. The reproductive cycle is kind of disturbing. Well, that's true for a lot of insects as well, but in particular, anglerfish has a weird life cycle, let alone its appearance and gimmicks, you know? Oh, that's fun. Hello, Delusionaire. Hello. Welcome. So that was a good example of, again, there's a lot of hypesters out there that want you to believe that um, generative AI is good for things like coding. And this little example right there is why it's not. So I'm setting up categories and I have time passed. So, time that has passed, or the idea that time passed, a sequence of time has gone by. But its suggestion, and this is tooltip, but it uses other elements of code and past code kind of patterns from me to determine what kind of stuff it should offer. And it's saying, well, the obvious thing that would follow time passed is time failed. Oh. But that is one of those aspects, is for every AI that is put, and it's deceptive to call them AIs, but for every large language model driven chatbot that is put to a task that would normally require a skilled individual, there is a skilled individual that has to intervene and make sure that the large language model chatbot did not screw something up. The people that are willing to implement that sort of thing don't realize that until, their chatbot does a hate crime or something. Or in the case of software, completely brings production down in some terrible fashion. Collision type, a time passed type. Oh, yes. The difference is there is a reasonable assumption that a junior programmer could eventually become useful to you, whereas large language models are dependent on either an evolving data set or a fixed data set, depending on what kind of, product you have acquired. Oh, okay. Sorry there, Delusion. We are making a game. We're making a Vampire Survivor style game. And, there's a lot of moving parts here. It's probably best that we start with the appearance of it. So some of the things are not wired in because we're still getting core systems in place. So the player object does not move right now. General premise, enemies spawn on the outside, move in. Player emits bullets, they move out. The gimmick that we're going for is to have a Noida-style weapon generation system. So we have the yarn balls, which have a base behavior of move out in a random direction. But I can drag and drop a modifier on it that says, as soon as you come into existence, split into 3. Or split into 3 and move in a spiral. And then wait 3 seconds and split into 3, but stop moving in a spiral. Yeah. So we're going for a bullet heaven, but with modular weaponry. So the thing that we're working on is we're going to change the behavior logic. And when I say behavior, I mean there is a class called a behavior. The fact that those were splitting into 3 or moving in spirals, that kind of thing, is controlled by a behavior. Currently, every physics step, we essentially query all the behaviors and let them do their thing. That is, in particular, what we do is every physics step for every entity, we go in and say, okay, run through all of your behaviors and have them do stuff. If it is a move straight line behavior, it gets told do stuff. And what that does is says, okay, I'm going to take the direction that I move in, and I'm going to propose that we move 1 unit that far. For reference, 96 is 1 world unit. Our sprites are 16 by 16, and the screen is zoomed in by a factor of 6. So 96 is 1 sprite wide. Those will become constants later, but we're working on it. So what we're adding to it, yes. Let me see if I have one of those loaded up so I can show you one of the cases. The reason that I say yes is not I don't view that as necessarily a negative. Because the weapon is modular, we are leaving the possibility open that you do something that is counterproductive with it. So do I have that? Let's targeters first. Okay, so we do have a move random direction. Pose direction. Random. Okay. Movement random direction. Okay. So we then go into our debugging logic here for standard inventory. do that in game? Hey there, Lunar. Not yet. If one behavior does 80 damage and then another behavior does 100, the first one would do a hit for 80, and then the second one would do another hit for 100. So it would tap twice. It is distinctly possible that the first one could finish the target off. And it would depend on what that particular behavior says should happen. And that's part of the trick, is the behaviors don't smush together. It will look like they do because it all flows together, but they're still distinct events. Where did I put that? Game. I thought it would be in standard inventory. Losing track of all the things. Process, template. Ah, here we go. We'll add a couple of move random directions here. Oh, but do those have icons? Definitely broke something here. Yeah, there's a flaw in move random direction. Let's find it. Okay, that's why. That's not a thing. No, it should. Movement at random direction. Oh, item. It needs an item. I remember now. Okay, we're going to start with a move right. That will help. Straight line. Okay. So the blobs by default move towards wherever my cursor is. That's not how they're going to move in the long term, but they do right now. Just the way it is. And the yarn balls move out in a random direction. Here's if I put move to the right on the yarn balls. Some of them speed up, but if you look, some of them slow way down. That's because the random direction that they move in is at odds with the move to the right. It's even possible, like some of them are hardly moving at all. And that's because the random direction might say move left. The move right is going to fight that and potentially zero out the movement. Here's what happens if we make the blobs move right. So you see the blobs on the right are not moving at all. Up by my ear. That's because they want to move to the left. But move to the right fights it entirely. If I put 2 move to the rights, then the move random direction can no longer entirely fight the move to the right. Then I can put a spiral on there, and now it will spiral out, moving largely to the right. Or spiral in, moving largely to the right. But because the spiral in happens at the end of the chain, the center of that spiral that it is trying to move into keeps moving to the right in that cone. So it never gets to the end of the spiral. But if we spiral first, it is spiraling on the random direction and it's being dragged to the right. So there is great complexity that can happen within the movement here. And, looping back to directly address the question, yes, there can be conflicts. And we want to make each item, each modifier, very attractive in its own way. Like, they should all do cool, impactful stuff, but that doesn't mean that every combination will be great. Yep. Lunar's got it. It is everything should chain into everything else, and that's what we're kind of thinking about right now, is how to make it so the way that the projectiles interact is part of that flow. That is, again, you could have 2 damage events, but they could be on either side of a gate. So it might be that the projectile does more or less damage depending on if it's crossed a gate yet. A gate is a thing. For the most part, currently gates are just time until the next chunk of behavior activates. But there will be other gates. All right, where were we? Okay. It's not an interaction message. Those are going away. There we go. So we're going to have different types of message. There will be broad stroke types that, like, there is a class associated with them. So, like it to be a property. Yeah. Okay. So how this will work is that there is a property called type that will return whatever get type returns. This will be overridden by the child classes. So when you ask it its type, ideally the subtypes are the child classes of a behavior message will override this and say this is what their type actually is. Now, I could just set this, but we're going to have child classes, and I think making this essentially a full constant is the way to go. Yeah, so things like take damage, deal damage, the project, like a death event, time has passed, all of those are going to be possible messages that we could have logic driven by. Like, for example, let's, under the model that is currently functioning, there is a lifespan timer. And what a lifespan timer does is it just keeps track of how much time has passed. If the timer expires and it is a child class of a time interaction, we're going to simplify that. All right, Florian, thanks for joining us. Have a good day. But if a timer interaction expires in the case of a lifespan timer, it just triggers the removal of that entity. Now, when I remake this, it is not going to trigger the removal. It's going to send a die message to it. Which technically an entity could ignore. But I'm going to make it so that that's almost impossible. But technically possible. There could be logic that says, hey, if this projectile would die, do this other thing real quick. You know, spawn another projectile. But by default, if it's a die message, there's going to be special handlers in place that say, once everything has had an opportunity to look at this message, this projectile goes away. Yeah, technically possible. And that's everything has had a chance to look at it. It's possible that one of the behaviors eats it and says, this message will not survive past this point. Hey there, Daniel. Well, welcome back. Yep. A defy death mechanic would be a way to handle piercing. We're still working on the game there, Daniel. As I'm wont to do, let's show off once again. We are sitting at, let's wait for it to stabilize. Yep. Okay, we're at over 100 frames per second, and we're at about 2,700, 2,800 things active with collisions. This will cost a little bit more frames per second usually. Yep. But in the it is a bit bullet hell boss going on here. Yeah, the slimes do not survive for very long. Now, part of that is you're actually witnessing a type of piercing behavior going on here, is that there is nothing about a collision between a bullet and a slime that does anything to the bullet. Right now, the bullet just has a special interaction on it that says, kill the entity you run into. I mean, it's technically a possibility unknown. We do have control over the lifespan. But would we? No. Oh, I like just playing around with this. This is demonstrating again. We can still see that the spiral is a very strong modifier. But the double move to the right is still pushing a majority of the things to the right of the screen. Iron Man 3? Okay, 2 was the one with the guy with the laser whips, wasn't it? What was in 3? I don't recall what was in Iron Man 3. All right. Real quickly, gotta step away just a moment. And we're back. Okay. In behaviors, we're going to change this to be we're going to make a message folder here. Hello, Peas. Welcome. At check here. Let's see. We have Sammy and Sky and Sherbet, and then Mason. Ember is on my shoulder, so all 5 are accounted for. Camera 8. There they are. So comfy. But welcome. Welcome, Peas. Welcome. We're working on our game. We're looking at a bit of another refactor here. We're expanding the use case of an existing object to encompass the use case of another one. It will simultaneously increase the complexity of one of the objects from a design perspective, but it will reduce the overall behavior complexity, I think. Hey there, Noodle. It is a bullet heaven game with modular weapons and upgrades. Like fully modular ones. So vampire survivors with Noida wands. We're still at a lot of like early setup. These are sprites I intend to use, but some of them are not being used what they're going to be used for. So again, we've got the enemies track the cursor because I don't have logic to make them chase the player built in yet. That's not a big deal, but it's... I want to make sure that the player is tracked properly this time. So they're all moving out. Right now we're emitting, I think 10 yarn balls a second and 2 blobs a second. Something like that. Might be 12 yarn balls a second. So we can go in and do something like this, where each yarn ball splits into 3. And then we can split into 3 again. So we're doing 9 twice a second. And then we make them move in a spiral. And we make them stop moving in a spiral. Yeah, bioprototype isn't much better. I like bioprototype in general, but I really do wish the dev would stop like trying to reimagine that game and re-releasing it with only like a moderate change to how it's presented. But let's see. There's Magic Craft. There's several like it, but effectively, if you look, I've got these little boxes down here. Again, this is an end state, but I've got these boxes and I've got icons in them. Each of these icons makes the projectiles behave differently. Like if I put this one in here, the yarn balls will favor moving to the right. If I put another one in there, they really favor moving to the right. If I move this one further down and I put a spiral in between them, that is different than if the spiral is in front of both of them. And that is different if the spiral is after them, because the behaviors are handled from left to right. Ah, well, I mean, that's kind of to be expected. We can also do things like it favors moving to the right, and then after 3 seconds, it splits into 3, moves faster to the right, and starts spiraling. Or it starts out favoring to the right, and then it will split into 9 and stop favoring to the right, and then wait for 3. Actually, no. There we go. But, confusing story shorter. We have a series of sockets that will be upgrades. Every one of those little sockets is going to do a lot of things at once, because we want everything that you could put in a space to be compelling. Like, you really want to try to use that one, but it's possible that combinations of the particular ones are not great. So this move to the right isn't going to be something that we actually put in, because it's not great. Like, moving to the right means half of the screen as far as offense is weakened. But additionally, you can see some of the other problems with moving to the right, and that's it fights with the base movement. The base movement to the yarn ball is to move randomly, as in it picks a direction at the start, and it wants to keep moving that way. Well, if we have a move to the right, that movement to the right could directly oppose the random movement. And if that happens, it just kind of sits still. And that's not good. What are you working on, Peace? One of the things that we've been working on recently and that I solved this morning is all of the collision that's happening is done on the GPU. So we're doing this all using a compute shader. All of the rendering of the yarn balls and the slimes and all of that is handled by a graphical shader, a standard shader. One possibility would be to essentially have you could have a movement type that tries to force cardinal direction movement. So it would look at it and say, which is the dominant direction? Is it right, up, right, down, left? Whichever it is, it would then try to assert that as the direction that it should move in. It is all smoke and mirrors, and I'm fine with that because it's letting us have 120 frames per second with 1900 things on screen. Well, there's also some off the screen a little bit, but And if we sacrifice more frames per second, we can get more things going. The limit is 24,000. If you hit the limit, it doesn't work great. For reference, after 3 seconds, the yarn balls split into 243 yarn balls. They will then proceed to live for 7 more seconds. I mean, it's a practice thing, Peas. The best way to develop skill at it is to keep trying. This is my first game project, and we are on stream 98. And the amount of work I've been putting into this off stream has been steadily increasing. But yeah, we can have about 17,000 active entities, and we're still getting a whole 5 frames per second. One of the reasons that I referenced Noida is back in the day, and you can still find VODs and shorts on my channel that reference this on my YouTube channel. Shameless plug, go watch my VODs and shorts. We played a lot of Noida. It is a very custom game engine game where every pixel is a simulated material. Really impressive. But on the channel, we modded it very heavily. Like, I wrote a custom mod to play with the community. And one of our jokes was that you know that you've built a really good weapon when you no longer have frames per second, but you have seconds per frame. And in particular, when we started to get minutes per frame. Because if you're going to make a cataclysmic weapon, you might as well break the entire world with it. And as far as this game is concerned, this is a cataclysmic weapon. Even with the even if we assume it would take many projectiles to wipe out a blob, or, an enemy, there is no way they can get to the player in this scenario. There's just too many things in the way. But again, 100% on the GPU as far as collision detection is concerned. Collision handling is on the CPU side. It can. Engine choice is largely a matter of developing the skill set for it. Different engines usually favor different project types. Like, I think Game Maker Studio is focused more on 2D interactions in games, but there's nothing that stops you from, with enough effort, using other engines for just about anything. Unreal is very powerful. You're going to be using a lower level language. But this is Godot, and instead of GD script, I'm using C#. And all of my collision logic here is in OpenGL shader language, which is C# with extra steps. I'm sorry, C++ with extra steps. But yeah, let's see here. So what we're currently doing, eventually doing, yeah, Unity, I didn't like the IDE. Is it terrible? No, I just didn't like it at the time. The system for getting libraries from outside into it was kind of a hassle. And I won't try it now because I don't trust the company. After the shenanigans they have pulled with their contracts, let alone just their general behavior. They've had some scummy people at high levels. We're going to be heading into a Twitch ad break shortly. I'm going to be fiddling with this class during that break for the time being, since I already had a get up and move around break a little bit early just a moment ago. So, okay, we have a behavior message. So the payload will be dependent on a particular implementation. Okay, so it extends behavior message, like override. Can I not? So this will be a time passed type message, and these have we want to call this. So there is, for a time passed, there is how much time is a segment, um, and whether the segment should repeat or not. Oh no, no, that's what a behavior would do. And the Twitch ad is ended. Okay, so our time passed will have a delta of some kind. Let's check. Okay, it's coming in as a double. One of the idiosyncrasies is the Godot side, both in the GD script and in the methods that you pass data to, like the physics methods, want a float for delta. But all of the C# side of the interfaces, including the ones that Godot directly calls, use a double for the delta. It's not like end of the world kind of thing, but it is an idiosyncrasy. Okay, so something comes through, it's going to say like, hey, I care about time past messages. Is it a time past message? If it is, well, how much time has passed? Let me look at that. And then based on that value, it'll do a thing. So for the purposes of the movement style messages or events, they're going to look at a message and say, if it's time passed, I'm going to use this delta to perform the movement and have the entity that I operate on be affected by that. Which, thinking on it, we need to have we would need to have references to an entity to act on. So effectively the owning entity. Behaviors don't fundamentally have that. Okay, we're going to have that be part of passing it, is when an entity gets a message. So right now, an entity is told to act. The behaviors are currently told what the entity is. That's going to continue. So it will be, behavior, handle message, the entity that is receiving the message, and the actual message, the payload to deal with. Okay. So it can entirely be this kind of structure. So the thing that makes a time passed message is that it returns this as its type. And it has a delta to it, how much time has passed. And when you initialize one of this type of message, you have to give it a delta. The delta will not change. Is that how we want to do it? Yeah, I think so. Do we want to have it be possible that a behavior that is taking a message alters it? So, for example, let's say time passed has come in. What if a particular behavior takes that and says, okay, for every subsequent behavior in the chain, less time has passed. So it cuts the delta in half. It does not consume the message, but it alters it. Because the messages are handled in sequence and are passed down the chain, that would allow... Yeah, we're going to let it change things. We should still make that part of the initializer. Of the constructor, because you should not have a time pass that does not have at least some consideration for setting the delta. to some extent, this is a... The fact that it's a type and it has an identifier on it is a bit double dipping, because I can just ask, is it a time passed message? And not have to worry about this part. But by having this here, we don't have to worry that... No, just knowing that it handles specific ones, I think would be good enough. Okay, so the thing I'm thinking on here is when I get a message that is coming through, there is always... everything is always going to look at it and say, is this a message that I care about? Now, one way we could go about it is call getType and compare that to a behavior message time passed. Like, I care about time passed messages. Is this type a time passed message? Well, if I want a time passed message, what I actually want is that there's a delta, and that delta means things. But what if there are other types of message that follow that pattern? This doesn't tell me anything about the interface. This does. If I need a time passed message because it has a delta and that the use case is that this represents a unit of time having passed, then I want this, or any of its child classes. But this could lie to me. I could have a time passed and it is not one of these and it does not have a delta. That doesn't work. I would then have to know about all of the types. So this is going away. Does that make sense? Abstract. For the time being, this is nothing. A behavior message never exists on its own. That is, you never do new behavior message. It will always be a time passed message or a collision message or that kind of thing. Okay, so we have time passed. Collision message. Extends behavior message. Okay. A collision message has a source and a target. In the future, there might be, like, where it happened. I don't currently have that information. Like, I could, but it's not wired up. Okay. So we have collisions, we have time passed. This should let us recreate everything that we've got here. So if we go up to behaviors, there are now going to be message handler. Things behavior. Behavior should require implementation. Yeah, we should have to implement iCatalogable. Oh. Trying to think of I'm looking to see if there's a hotkey for, hey, I should implement an interface here. You'd think it would be a quick action, but oh well. Let's actually get okay. This is an extension of an interface from the parent class that is in behavior. And what this says is, I'm going to get one of these that I intend to copy, and I'm going to apply all of the corresponding things to the copy. If relevant. lifespan message handler, we are going to have a only lifespan. It's a read-only double. It can't be read-only if we want it to work this way. Okay, you are either creating it with a lifespan or it's going to duplicate its lifespan. Let's close others so we can... oops. Okay, if it doesn't equal null, then we do that. Okay. Is a lifespan message handler. Copy. That is as a lifespan message handler. There we go. So this is what happens if we copy Okay, so we have what's the max lifespan? This would be read-only. This should not be getting changed outside of the creation period, where we're going to create one through this. And then... Yeah. We'll create it, then you'll set the lifespan. When it begins dealing with messages, it's going to increase the time passed by the delta in the message that it's listening for. And then, once that happens, once that is triggered, Like, if time passed crosses the threshold, it will raise an event to kill the entity in question. So, in behaviors, we now need a handle message. This needs to be there, but some behaviors don't care about this. Yeah. Same with this. I'm probably going to have a subclass that is a movement behavior that has a targeter. By default, behaviors don't care about messages, and for movement behaviors, this will stay true. Well, sorry. Almost no behavior should do this. In fact, this should probably have to be abstract, this one here. A behavior should never be a standalone thing. Yeah. Hello, diminished. Oh well. Virtual it is. So I saw you join the dev chatter board there. We are having a good day because we did actually get collision working. So right now, if Yarnball touches a blob, the blob goes away. And we can handle quite a few entities at once with collisions happening. Nice. I'm glad you enjoy it, Diminished. Aside from me getting to continue exploring game dev, which is something that I've really wanted to do for a while, a core factor of this is to be entertaining for you. Yeah, right now we've got, a little under 3,000 objects, and we're still at 1,000, like upwards of 100 frames a second. That's just peachy. And we can get upwards of 20,000 while still being at frames per second. Like we can have 5 frames a second at like 20,000 things whirling around, which is beyond what you should get in normal gameplay. Okay, so now we pass messages to the behaviors. So there's going to be a bit of a song and dance in getting this next part done. Is we need to get we need to be replacing act with handle message time passed. So let's start by going into our entity manager here. Check. Okay. Standard entity manager. So we go down to here. So we figure out which entity it is in the collection, and we're calling act on it. Load up a new time passed message. And then we're going to say entity dot handle message. Oh, no. It's not here. Entity has to have handle message on it too. So act is largely going to be is pretty much entirely going to be replaced with entities. Will never, when they get a message, it doesn't matter whether they respect it or not. Okay, we can interim this. Okay, we're short-circuiting this for the time being. What we should be able to do is in the entity manager, instead of act, we are going to do this. Everything should behave as it did before. Ta-da. Why is this relevant? Because this creates a pattern for us to say that anytime we get a message that comes in, or anytime we want to interact with an entity, we throw a message at it, as far as the game world is concerned. So we would do this. So when an entity gets a message, if the source of that message is relevant, as far as like another entity is dealing damage to us, if the entity that is dealing damage is relevant, that will be part of the payload. Ideally, the entity that emits that is going to be able to say, "This is me, I'm doing this." But as far as handling the message, like when we go in and pass it to a behavior, the behavior needs to have an entity on it. Okay, so when a behavior handles a message, we are going to go in and pass to that behavior, essentially this, comma, the message we're relaying. So right now we're just calling act, but we're not really going to do that. We are going to pull all of this together. It shouldn't be for every message, though. We're going to need another message that is, or another function that is just essentially saying update. So that will be like a physics process step for it, where all that the entity is going to do is update its proposed movement and then set it back to 0. But will it? Okay, bit of a tricky thing here. Facing does become relevant. But no, we tell everything when we update position. We tell everything this was our facing at the time. So anything that cares about the facing will keep that information for it. Visual information, largely. I don't ever want to have gameplay stuff related to which way the entity was facing last update. So the worst weapons in survivor style games are almost universally the ones that behave like the knife in Vampire Survivors. That is, whichever direction your character last moved is the direction the projectile will fire. That is one of the most limiting ways you could make a projectile behave. Okay. So when we update position, we're going to zero this out. Okay. So right now it says act as far as okay, we're going to need to go further than this. We have to start going through each of the behaviors and updating it. And for the time being, oof. Targeter update is only relevant when something moves. It is distinctly possible that some of these messages will not involve movement logic. That is, updating the targeter is not relevant unless they are a movement behavior. Because target only matters if we're moving. Random direction, to the right, that kind of thing. These are largely becoming irrelevant, but there's still modularity to this that is useful. Okay. Let's start getting that in there. Then in a behavior, we have this guy right here. Okay, movement behaviors have targeters. Regular behaviors don't. This will cause problems. Yeah. There's a lot of refactoring that needs to be done. Largely no. Largely no. It is going to have a ripple effect when we do this, though. So, real quickly. Commit. So again, the thing that's going to have a ripple effect is when I take this out of here and put it in movement behavior. Why? Because a whole lot of stuff references targeter as if it were a fundamental part of behavior. thing that makes a movement behavior is that it has a targeter. Everything else is up in the air, but movement has a target, whether it's a direction or an entity or something. It has something that indicates where it's going. How it interprets that, up to the individual behavior. Again, this is going to ripple outward. So we need to go into all of these and call them movement behaviors. Because if they're not a movement behavior, then they won't have a targeter. Spawners don't necessarily care about a direction. But all behaviors need to handle the idea of being rotated. So that's still okay. A movement behavior. We override rotate. And in a actual regular behavior, rotate does nothing. Time being, we do this. By default, we don't do anything related to a targeter when we act. Should get a lot of errors here. Okay. Spreads don't have targeters. Groups don't have targeters. And then by default, an empty behavior does not have a targeter. Or that is, it will do nothing. Or it's not a movement behavior. It does not have a targeter or any concept of one. Again, everything should work, right? I have 5 cats diminished. You can see 2 of them up there. That's Sky in the back. He's one of the 2 largest. He's extra fluffy. In the front of the tree there is Sammy. She is the second smallest. She's a little tuxedo. So across from my keyboard is Ember. She's itty bitty. She is a diluted calico. On the bed there, on the little squishmallow and a folded comforter, is Mason on the left and Sherbet on the right. They're all little sweethearts in their own way. There's a bit of overlap. Sky is big and fluffy, and he is gray and white. You can't really see clearly because Mason is curled up tight and Sherbet's kind of sprawled. But Mason is noticeably larger than his brother there. It's unclear whether they were the same litter or they had the same father. But Mason and Sherbet were brought into the shelter together, so there's an assumed relation between them. But they have really distinct differences to them. Fur type, body, kind of general body conformation, size. But Mason is noticeably larger than Sherbet. This camera is zoomed way in, but Ember is very small. Ember is very snuggly. She'll crawl up and like lay on my shoulder, that kind of thing. Sammy will come and sit on my lap. Sherbet will actually climb up on the headrest of my chair and want me to pet him up behind my head. Okay, so everything's functioning. So then we're looking at a behavior. Currently, we have the concept of taking an action. That's not really what we're doing. We're going to go into... should be entity manager, actually, but... is that hiding? This is physics process. We're going to rename you to physics update. Did that impact this? Yeah, excellent. Okay, we're calling it that because it makes some sense over here on the entity side. To have a method called physics update. Which is currently here. We don't actually want this to be a physics update, though. In the entity manager, actual entity manager, when we do a physics update here, we are going to trigger an event handler across each entity. And then at the end, we are going to say entity physics update that. The entity's physics update is just going to apply the changes that it made. I'm going to continue to pass delta into it, but ideally it won't do anything with the delta. So what we're going to do is we are going to change it to essentially this. It's not a comment block. We're going to entity update position. And then we are going to zero out proposed movement. That's what physics update is going to do. It is actually going to apply the movement that happens after we handle the message. Then up here, message. Okay, you tell the behavior, the base behavior, here's a message. Then we're actually going to wrap this. Say if so if the base behavior doesn't eat the message, so if it handles the message, it's going to return true and say the message is done. I could make this explicit by having a Boolean setting it to that regularly as handled message. Let's actually do that for readability. Still going to be a not. So if it didn't consume the message, we're going to go through all the behaviors. So if there's a gate, we're going to try to handle it there. We need to go into the gates and update those, because try open should be getting a message instead of a delta. how are we going to do? We need to update behavior group as well. Because when it comes to an entity actually taking actions, handling messages, it's never dealing with just a behavior. It's always dealing with it as a group, as a composite of multiple behaviors in sequence, so that we can do this song and dance here. Handle message. This message. Within a behavior group, we are going to have, while it's looping through the behaviors, we have to have an extra check that says, is this handled? So let's go into the gate then. It will get a behavior message. Then a timer gate. If message is time past message, time past message, time past is equal to message as time past message. Message dot delta. Okay, gates should never consume a message. I'm gonna unilaterally say that gates don't eat messages. Either the gate won't open and the existing behaviors handle the message, or the gate opens and the subsequent behaviors handle the message. Okie doke. Message. Okay, timer interaction cease to be. This will cause some issues during the initial testing here for a moment. Okay, so we do a physics update at the end of the entity manager loop. Okay, so we pass in handle message. Now we go to behavior group. Click override handle message. Handle message is going to do is it's going to iterate over each of these. I is 0, I is less than behaviors dot count and not message handled I plus plus to behaviors I no message handled is equal to behaviors I dot handle message entity message. Turn and message handled. Okay. um, all movement behaviors don't necessarily care specifically about it being a time passed message. They could react to any kind of message and take action on the entity accordingly. Okay, so then we have entity. We're going to call handle message on it, which should be calling it on a group. So then in entity manager, standard entity manager, we do not call physics update here. We enqueue them. We call handle message. We send a time passed message, and we do a physics update at the end of that. Okay, yeah. Because so then we're going to go into entity and in physics update. We're going to say if proposed movement zero okay, so if there's proposed movement, then we're going to apply the movement and we're going to zero out the movement vector here. Okay. Okay, so in the physics loop, we call time passed on the entity, and then we update its physics. Then in each of the movement behaviors, we need to have handle message come into play. So rotate is correct for a movement behavior. That should be true. When it takes action, we should update targets. We should always update targets based on a delta if it's a time passed behavior. How do we want to do this, though? because it's distinctly possible that a child of movement behavior doesn't care about movement messages. So what we'll do then is public virtual because in general, we want the targeter to be updated. When we get a time passed message, targeters are going to care about that delta. This one's tricky. This one's tricky. All right. I think that is our call to wrap up for the night because I am going to need to think on this structure a little bit more. Um, we need a way to say if it moves, if it's a movement behavior, we can handle the messages, we can handle the targeter part of the messages properly. So, what we're probably going to do is have a parent class handle message, and that the child class says, oh, I'll call the parent. But we need to be cautious of that because it might be that a subsequent child needs to override that. So we'll see. We'll see. But with that said, I hope everybody had a good time watching with us tonight. If you had a good time and would like to see more things like this, remember to like, follow, subscribe, comment, all that good stuff. It helps the channels grow. And with that, I hope everybody has a good rest of your day, and I will see you next time.